much else to do. So yesterday I wanted to, as I explained, I still need more magnets for the rotor assemblies to configure the rotors properly, because it's not completed yet. I probably need to get another 40 or 50 magnets actually. And yesterday I did discover that I have a few magnets in this half of a segment, which I forgot about. But it's not enough by any means. I need at least 50 additional magnets. I have been working on some new ideas to improve it even further. Now, I did a test last night, and I had an interesting discovery. So I moved my power supply, which is running the small motor. I moved the power supply onto the windowsill because I got sick of tripping over this wire, and by moving it, it's running on the another thing I want to tell you. I've now connected the power supply that's running the motor generator. It's now connected to my uninterruptible power supply, which is also on the windowsill, because I realised that this is regulated. And because the uninterruptible, this old backup power supply, which I made the new battery for, do you remember seeing that in the previous live stream? I made a new battery pack for this. This is regulated AC, and instead of having them annoying problems with mains fluctuations, do you remember the voltage was going up and down, and it was causing the generator to speed up and slow down, speed up, slow down, and it was creating a lot of frustration and confusion with my measurements, because anyway, I realised connecting it to the ups, which is down here on this brick thing, connecting it to this ups is now making it stable, so the voltages are no longer fluctuating. Now, I'm still running it at 6 volts, so that's 6 volts, and it's still picking up speed, and the current, it drops to about 180 milliamps once it picks up full speed, but it's still, the current consumption is still picking up. So this drops down to about 180 milliamps when it picks up. Now, because it's using a stable voltage, yesterday I was doing some tests, and this has been up to 1160 RPM. That's at 6 volts, which is really quite surprising. As you can see, it's still picking up speed, because until it picks up full speed, the current will be quite high. So what I did yesterday, I did an interesting experiment. I wanted to determine how effective the anti-drag system is on the rotors, because the middle one is the anti-drag rotor, and the two outside ones are a combination of generator rotors, because they've got the generator magnets facing outwards, and also series consecutive, but there's magnets missing. As I explained, I need an extra 50-60 magnets or so, or actually 48 technically, but if I wanted to double up the actual magnets, I'd need about about 90, is it 93 or something like that, but that's going to cost me a lot of money, and I haven't got the money right now, so I'm having to save up for that. The interesting experiment I did yesterday was to reverse the polarization on the drive. I actually spun it backwards. Now, when I reverse this, the reason I'm going to explain it and not demonstrate it is because it takes ages and ages for it to settle, you know what I mean? So I was running it backwards, and then by logic that the drag should increase, and it did, because when I run it backwards, I had a speed of about 100 and on the RPM, I had a speed of about 117, 120 RPM when it's running backwards. But when it's running forwards, when the anti-drag system works, because the anti-drag is actually adds drag when it's running backwards, you see. So when it was running backwards, it was about 117 or something. And when I run it forwards, it goes to, sorry, 1017, sorry. So when it's running forwards, it goes up to 1160 RPM. So that proves that the anti-drag system, which I've got in there, is working, because, and I didn't change anything, the LEDs are still connected up, which are lit up slightly. The LEDs are just a bit of a reference. I don't want to change them at all at the moment. This is just all experimental. Oh, I've got two LEDs now, back to back, so they make full use of the AC. So one LED lights up on one half cycle and the other LED lights up on the other half cycle. So they're basically wired back to back so that we make use of the AC. And it's just really a measuring point, because it also helps have a small load on the system. When I make improvements to the segments, when I make the improvements that's beneficial, it will speed up and I'll get the same current, you see. That's the idea. But it has actually sped up. So I actually did change some of the magnets. I moved, let me see if I can show you on this one. So on this segment, what I actually did, this has got too many magnets in it. Well, actually, I'll show you on this end. So what I did was I removed the magnet that's in this slot here, and I reversed the pole, flipped it around, I stuck it in the lower slot down here. And I did the same on this side, but this has got too many magnets in right now. But so that one's vacant actually in the rotor assembly, and this one's also vacant on the rotor assembly. So I had a magnet there and a magnet there. So I changed the orientation of these magnets on all the segments, so that we could get, and actually on the rotor assembly, this particular magnet here is missing. So we have a magnet there, magnet there, magnet there, then a gap, then a magnet there, a magnet there. So I was doing this test yesterday, and as I said, by having it rotate in the reverse direction, which is in this direction, that is with this thing moving that way, it was increasing drag. When this thing was moving in this direction, it reduced drag. So the array does seem to be helping. Now, what I've been visualizing and what I've been thinking about is that the orientation of the drive magnets which generate the power, which are these magnets here and these magnets here, need to be configured in the shape of an arrow. That's the next step, but I can't afford to print those yet because I need to get some more filament, because I don't want to make you dizzy. My filament is virtually gone, so I've got to get more of that as well, and I can't afford that either at the moment. So I've got to decide whether I want to get magnets or filament right now. So I think obviously I'm going to have to get the magnets sorted out somehow. Got to find some money for that. But I was thinking about having a V-shape magnet array for the drive, and then back supporting it with a magnet down here that's horizontal to improve the field. The reason for that is, as you know, the anti-drag system, let me just use it on this other segment array, which is this one, to show you what I mean, because anyone that's just joining. So when we have the biasing of the lens effect, the anti-lens effect comes into play, it will push that segment in the opposite direction, right? As we know, right? I'll stick that there like that. Maybe I can show you a bit better. But basically, when there's a lens effect, it will push it along like that, right? In the forward direction instead of reverse, you see, like it'll push it along in the forward direction. The lensing effect of the coils energized on the canopy will get this flipping drill bit stuck to it now. Get off, stupid thing. Oh dear, mate. So I think I've got this right around. So yeah, that pushes the lens effect was pushing it along. Now the other thing I found out yesterday was by moving the canopy with the coil assembly, when I moved it closer to the rotor, I got it seated properly, it actually speeds up, so that works. So when I move this canopy a bit closer and I move it, when I back it out, it actually slows down. I don't want to move it right now because I don't want you to start catching anything on it. It's a bit awkward with one hand as well, but I don't know if I could show you that. I'll try anyway. See without, hopefully it won't start catching. We're 1111 RPM right now. So if I try to back this out a bit, remember we've got the LEDs lit up under load. I'm trying to get, I don't want this catching or anything. Ah, it's hooked in there. It's really hooked into the pegs right now. Oh shit. I'm frightened to move it because it's hooked in there really tight. Oh shit, can't get it out. Oh, I'll just leave it. I can't get it out. Anyway, when you back it out, I can't do it with one hand. I need to hold this thing, and I need to hold this while I'm pulling on that because it's clipped onto these holes and it's in there pretty good right now. If I try to move this right now, the belt's going to come off. It's going to mess up the experiment, so there's no point. But it's still picking up speed, right? So yesterday I got this seated properly, and when I did that, when I got it seated properly, it actually increased in speed. And I'm thinking, wow, that's cool. So that means that the coupling between the coils and the magnets can be increased. It can be moved closer, but I can't get any closer than that because the gap between the rotor and the canopy is pretty small, as you can see from that there. See the light going through the gap. It's very, very close. Can't go much closer than that. So see if I can get up. Anyway, it's interesting, but we are definitely making some positive progress, and I wanted to just give you a heads up on where we are right now. And everything sticks to this thing. So anyway, I've got to basically get some more magnets sorted out, and then we can get this thing finalised and tweaked even better. So let's go and check current input at the moment because it's picking up speed. It should have dropped considerably. We might be around we're at 200 milliamps current consumption right now. It usually drops to I think about 180 or something. I think I said 160, but it's about 180 normally. It's at 200 milliamps at 6 volts, which is pretty good. It's at 6 volt range. Maybe 6.4 volts. Back to current. Yeah, this thing takes a minute to sell. The needle's sticking. Yeah, it's about 100. Yeah. Yeah, there's a shadow on it. Yeah, it's dropping anyway. So anyway, I thought I'd give you an update. Thanks for watching. I haven't got much else to do right now until I've been playing with it for a while, tweaking it, and not much else I can do until I get some more magnets, and also need to get some more filament. I'll give you some more updates later on. It's pretty quiet. Bye for now.